the same solid structure, and that crystal structure is called alpha. So above it is liquid, below it is solid alpha. In between anywhere, it is liquid plus the alpha solid. So for our example, when we start with a 53 weight percent nickel material, liquefy it, make it completely liquid and start cooling at 1300 Celsius. This temperature line intersects with our original material at this point. So if it is at this point, we immediately know that it will have some liquid and some solid. If we were here, it will be all liquid. If we were here, it will be all solid. Inside, it has some liquid and some solid. So this is the first answer to our question. If you give us a phase diagram, say of copper and nickel, if you give us an original composition of the alloy which we want to study, here a 53 weight percent nickel alloy, and if you give us a temperature, here 1300 Celsius, then your first question is that for a 53 weight percent nickel alloy at 1300 Celsius, what phases will be present? This is the first question always. What phases will be present? So what do we say? We will have liquid phase and solid alpha phase present. We will have liquid phase and solid alpha phase. Had the question been that for the same alloy, what will happen at 1400? This is the vertical line. What will happen at 1400 Celsius? It will cut it here. So the answer to the first question, what phases will be present? Only liquid phase will be present if the temperature was 1400. If the temperature was 1200, we will draw this line and cut it here. So what will be the answer? What phases will be present? Only solid phase will be present, right? At 1400 Celsius with 53 weight percent nickel alloy, only liquid will be present. At 1200, only solid will be present. But if the temperature is 1300, then we are between the liquidus and the solidus lines. So our answer is that both solid and liquid phases will be present. So what are the two phases present? Liquid L and solid alpha. So this is right. This is the temperature. So here now you can take a small break. You can assume that we are in the middle of the class somewhere. So don't proceed further. I will also pause here a little. And you can also pause here, go take a few sips of water or something, and then very shortly we will start again. Welcome back. I hope you have taken some small break and you are now doing it. So now see, we are on this phase diagram, and we have already explained to you the terms liquidus line, solidus line, tie line, composition of the alloy, temperature, and so on. And we are doing this example that if we give you a 53 weight percent nickel alloy, which automatically means that there is 47 weight percent copper mixed into it, and we heat it to a high enough temperature so that everything is liquid, and then we cool it. So once we reach a temperature of 1300 Celsius, then what will we have? What will we have means the first thing is that at 1300 Celsius, how many phases will be there. So you found out that you will draw a vertical line, you will draw a horizontal line, you will see where they meet. So you will say that there will be two phases. The two phases will be liquid and solid alpha. The second question now will be that for the liquid phase, what is the composition of the alloy, and for the solid phase, what is the composition of the alloy. So you will go back to this point. It cuts the liquidus here. So this is the liquid phase. This cuts the solidus here. So this will be the solid phase. So the liquid in this mixture, there will be a mixture of liquid and solid here. So the liquid will have this composition. So the composition of the liquid phase at 1300 Celsius will be 45 weight% nickel, which means 55 weight% copper, right? Do you understand that there will be two phases, liquid and solid, at this temperature? To find the liquid phase, we cut this temperature with the liquidus line, we draw this vertical line, we find the composition. So the composition of the liquid at this temperature is 45 weight% nickel. Similarly, we cut this line with the solid, read this. So the composition of the solid phase is 58 weight% nickel. If you see they are writing W, W, W here because of weight%. We could write M here for mass%. So this is the weight% solid, this is the weight% original material, this is the weight% liquid, isn't it? So that is a very good thing, that when we are here, the original material, and we cut with this temperature line, then this is the composition of the original, this is the composition of the liquid phase, this is the composition of the solid phase. So what is the first part of the question always when we are giving you a phase diagram? That we give you an original alloy composition and a temperature. At this temperature, for this alloy, how many phases are there? That is the first question. So here we have two phases, liquid and solid. Second question, what is the composition of these phases? So the composition of the liquid phase is 45 weight% nickel, 55 weight% copper. The composition of the solid phase is 58 weight% nickel, that means 42 weight% copper. So when you write, you should not write only 58 weight% nickel. You should write the full 58 weight% nickel dash 42 weight% copper, so that the full answer is there, right? So this is the great advantage of a phase diagram, that if a phase diagram is there, then for any given composition of the alloy, any 20% nickel, 80% copper, 70% nickel, 30% copper, any composition of the alloy and any given temperature that we want to find out. So you see, this is brilliant, that if you were actually making a copper nickel alloy and you were mixing some material, right, 20% of this, 80% of this, 10% of this, 90% of that, even before going to the factory where you make this, you can find out by this phase diagram that if I have this original, then at every temperature while cooling, what changes will happen, what phases will be there, how much liquid will be there, how much solid will be there, and for the liquid, what will be the composition for, right? So this is a brilliant thing. So you see, if you now see this diagram, try to look at it for some time and tell me if there is any word or anything in this diagram that you don't understand. Right? Just look at it for some time. I think now you know everything. This whole thing is a phase diagram. This is a phase diagram between copper and nickel. The vertical axis is the temperature line. The horizontal axis is the composition line in terms of weight% of nickel. There is a liquidus line. It is called liquidus because above it the metal will be liquid anywhere. There is a solidus line. It is called a solidus because below it, it will be pure solid. This material, this alloy, copper nickel, is a binary isomorphous alloy. Binary because copper and nickel, there are two materials in it. Isomorphous because once it is solid, there is only one solid only solid structure, which is called alpha everywhere, right? So this is an alloy of copper and nickel. This is binary because there are two materials which we mix together. This is isomorphous because once it becomes solid, there is only one structure, alpha. There is a liquidus line, there is a solidus line. At any given temperature, we draw a horizontal line. The portion of this horizontal line which is between the liquidus and solidus is called a tie line. And using this diagram, we can find the number of phases at any given temperature, and we can find out the composition of the liquid phase and the solid phase, right? Is there anything else? This is just an example.